Hey guys, in this video we're going to be doing section 4.5, which is adding and subtracting unlike fractions. Okay, what are unlike fractions? Well, in the previous section we learned that like fractions are fractions with exactly the same denominator. Well, unlike fractions means fractions with different denominators. Okay? Different denominators. Okay, that's what the word unlike means. And a lot of people hate these, I'm not going to lie. It is one of the hardest things in fractions is when they don't have the same denominator. But the basic idea here is if you want to add or subtract unlike fractions, you're going to need to build each fraction so that it has the same denominator. So you build to a common denominator, and then once you have the same denominator, then you keep the denominator and you add or subtract the numerators. Okay, so build to a common denominator. Build to a common denominator. And what does that mean, build? Well, you have to multiply on the top and the bottom by whatever you're missing. Okay? Alright, so let's see an example of this. Oops, pressed the wrong button there. Okay, so example. Instructions are add or subtract. Add or subtract. And for example number 1, we're going to be doing 1/5 plus 7/10. 1/5 plus 7/10. So the trick here is you need to build to a common denominator. And when I say build, I mean you have to multiply each fraction on the top and the bottom by whatever it's missing. So the common denominator that most people use is the LCD. Okay. So the most common denominator, the lowest common denominator is called the LCD. Now you don't have to use the LCD. As long as they have the same denominator, it's good enough. But most people build to the LCD. But here with this problem, you basically just multiply by what you're missing until they have the same denominator. That's your goal. Okay? So let me write that down. Multiply by what is missing in each denominator. And when you multiply, you have to actually do it on the top and the bottom. You can't just do it on the bottom. Okay, so here our LCD would actually be 10. But even if you don't want to do the LCD, you can see that you want them to have the same denominator. So you have to multiply by what you're missing. Here we have a 10, here we have a 5. Well, what are we missing here? We're missing a 2, because 2 times 5 is 10. So we're going to multiply this first fraction by 2 on the top and the bottom. And you actually have to multiply on both the top and the bottom. You can't just multiply on the bottom. And the reason for that is otherwise you'd be changing the fraction, which you're not allowed to do. So I saw that I was missing a 2 on the bottom because 2 times 5 is 10. So I multiplied the top and the bottom of the first fraction by 2. Okay, and as always, you multiply straight across. Okay, so after I do all that, what do I get? Well, for the first fraction, 2 times 1 is 2, and 2 times 5 is 10. So we have 2/10 plus 7/10. 2/10 plus 7/10. And notice now that we have the same denominator, the rest of the problem is the same as the previous section. So now all we do is, now these are like fractions, so we keep the denominator and add or subtract the numerators. Okay, so now these are like fractions. So we keep the denominator, which is 10, and then we add or subtract the numerator. So here, we're going to have 2 plus 7 on the top, 2 plus 7 on the top, and then we keep the denominator, which is 10. So we actually have 2 plus 7 all over 10. And then we can simplify this. We know that 2 plus 7 is actually 9. So we get 9 over 10. 9 over 10. And because this fraction is already simplified, we're done. Okay, so our answer is 9 over 10, or 9/10. So again, this whole process is harder for a lot of people because we ended up having to do an extra step. And the extra step, we multiply by what we are missing. Alright, cool. So we're going to be doing a lot of examples of this because these are kind of challenging for a lot of people. So hopefully you'll get the hang of it. So example number 2. Example number 2, we have 2/3 minus 1/8. 2/3 minus 1/8. So just like I said in the last problem, you want to multiply by what you're missing in each denominator. And with this one, it might be a little bit harder to tell what you're missing, but you do want to build these so that they have the same denominator. So one way you can do this is you can find the LCD. And there's a lot of different ways of finding the LCD, but probably the easiest way is you list the multiples of the larger number until you find a number that the smaller number also goes into. Okay, so LCD means list multiples of larger denominator. List multiples of larger denominator until we find one, until we find a multiple that the other denominator goes into. Okay? So until you find until you find a multiple that is divisible by the other denominator. Now you don't have to do the LCD. And me, for example, I would just look at these two numbers. I'd look at 3 and 8, and then I'd think, oh, well, 3 times 8 is 24, so the LCD is 24. So if you can just do that in your head, many times that's the easiest. But if you want to list multiples of the larger denominator until we find one that the other denominator goes into, that's going to give you the real LCD. So I'll do that, just this once. Okay, so here, to find the LCD, we look at our larger denominator. So here the larger denominator is 8, and we list multiples of 8. Okay, so the multiples of 8 are 8. Well, 3 does not go into 8, so we cross that out, and we go to the next multiple, which is 16. Does 3 go into 16? No, it doesn't. So we cross that out, we go to 24. Well, does 3 go into 24? Yes, it does. So that means 24 is the LCD. Okay? And then what do? We still multiply by what's missing. but we're going to multiply by what's missing until we get the LCD. All right? And again, you don't have to do the LCD. If you want to, you can just build them to any common denominator. As long as they're both having the same denominator when you're at the end of the problem, then you can combine them. Okay, so here, 24 is the LCD. So what are we missing from this first denominator? Well, what times 3 gives me 24? 8 times 3 gives me 24. So I'm going to multiply this first fraction. Oops. What did I do? Oh my gosh. Sorry about that. 8 times 3 is 24, so we're missing an 8 for the first fraction on the top and the bottom. And then for the second fraction, we have an 8, but we want 24. So for the second fraction, we're missing a 3. So we're going to multiply the second fraction by 3 on the top and the bottom. Okay, and after we do all that, then for our first fraction, we have 8 times 2 is 16 over 24. And then for the second fraction, we have negative 1 times 3 is 3 over 24. So we actually have 16 over 24 minus 3 over 24. Okay? And then now these are like fractions, so they have exactly the same denominator. So we keep the denominator and subtract. Okay, so here, we're going to be subtracting, and that's going to give us 16 minus 3 all over 24. Okay? And 16 minus 3 is actually 13. So we get 13 over 24. And 13 does not go into 24. And so 24 and 13 don't have any common factors. So 13 over 24 is actually our answer. Okay? So that was a little bit more challenging problem. Now, a lot of people find these hard. So we'll do lots and lots of examples, and hopefully you'll get the hang of it. And I will be using the LCD on some problems, whereas in other problems, we won't bother finding the LCD because it'll be obvious by what's missing. But with this problem, it might not have been obvious to you what we were missing. But you want them to have the same denominator. So if you want to write down the LCD, that makes it easier. Makes it easier to know what you're building them to. Okay? Alright, so let's do example number 3. Example number 3. This one is negative 5 over 14 plus 5 over 28. Negative 5 over 14 plus 5 over 28. Now with this one, you might not need to write down the LCD because it should be obvious to you what is missing. Because here we have 14, here we have 28, and we know that 2 times 14 is 28. So you should be able to see that what we're missing in this first denominator is a 2. Because we want them to both have the same denominator, so we multiply this first fraction by 2. And of course you have to multiply on the top and the bottom. But this one's actually easier than the last problem, so hopefully you don't need to write down the LCD for this one. Okay? So multiplying, we get negative 5 times 2 is negative 10 over 28 plus 5 over 28. Okay? So negative 10 over 28 plus 5 over 28. Alright, and now these are like fractions. So we keep the denominator and we add or subtract the numerator. Okay, so what this is going to be is we're going to have negative 10 plus 5 all over 28. Okay, so we kept the denominator and we add or subtract the numerator. And then negative 10 plus 5, because they're opposite signs, we subtract and we keep the sign of the larger number, which is 10. So that's going to be negative 5. Okay, so we're going to get negative 5 over 28. And 5 does not go into 28, so there's no common factors. So this is actually going to be our answer. So our answer is negative 5 over 28. Okay, so hopefully that one isn't too bad. It's a little bit easier than number 2. Okay, let's do problem number 4. Okay, problem number 4. This one is 3 minus y over 10. 3 minus y over 10. So here, this one's tricky again, because it doesn't have a denominator for the 3. But remember, if they don't write the denominator, what is the denominator automatically? The denominator is actually 1. Okay, so this is actually 3 over 1. Even though they didn't write it, that's what they mean. And then this one, again, it's easy enough. We probably don't need to find the LCD, because here we have a 1, there we have a 10. So what are we missing here? Well, we want it to have the same denominator, so what do we multiply this by? We multiply everything by 10 on the top and the bottom for the first fraction. So we multiply the first fraction by 10 on the top and the bottom. Okay? So what does that give us? Well, on the top we have 10 times 3 is 30, and on the bottom we have 10 times 1 is 10. So we have 30 over 10 minus y over 10. Okay? 30 over 10 minus y over 10. And then now these have the same denominator, so they're actually like fractions. And since they're like fractions, we keep the denominator and then we subtract on the top. So on the top we have 30 minus y, and on the bottom we have 10. Okay? And because 30 and negative y aren't like terms, we can't combine these. And I know it looks like you should be able to divide the top and the bottom by 10, but you actually can't, because the y doesn't have a 10. Okay? So I know these two have a common factor, but the y doesn't have a common factor, so you can't actually simplify this. So our answer is 30 minus y all over 10. Okay? Cool. All right. So problem number 5. Example number 5. For this one, we have 7 over 12 minus 4 over 9. 7 over 12 minus 4 over 9. Okay. So with this one, it might be hard enough that you need to actually do the LCD, because it might not be clear what you're missing from each denominator so that you get the same denominator. Okay, so what I recommend is that you just go ahead and find the LCD the way I showed you. Okay, so for the LCD, remember you look at whatever is the larger denominator, which here is 12, and you start listing the multiples of 12. Okay, and the first multiple of 12 that 9 goes into is going to be the LCD. Okay, so if we start with 12, we know that 9 does not go into 12, so I cross that out and I go to the next multiple. Well, the next multiple of 12 is 24. Does 9 go into 24? No, it doesn't. So I cross that out, I go to the next multiple of 12, which is 36. Does 9 go into 36? Yes, it does. So that means the LCD is 36. Okay? So the LCD is what we're going to be building this to. So we need to multiply each fraction by what we're missing in the denominator. But from your times tables, that shouldn't be so bad. So looking at this first denominator, what are we missing here? Well, we know that 3 times 12 is 36. So here we need to multiply the top and the bottom by 3. Okay, so we'll multiply the top and the bottom of the first fraction by 3. Now in this, in this second fraction, in this denominator, what are we missing? Well, 9 times what gives you 36? Well, we're missing a 4, so we multiply the second fraction by 4 on the top and the bottom. So 9 times 4 is 36. Okay, so we're building each of these fractions to the LCD by multiplying by what we're missing so that we get the LCD. Okay? And then multiplying straight across, what do we get? 3 times 7 is 21 over 36, minus 4 times 4 is 16 over 36. So we have 21 over 36 minus 16 over 36. Okay? And then now these are like fractions. So they have exactly the same denominator. So we keep the denominator and subtract on the top. Okay? So that's going to give us 21 minus 16 all over 36. 21 minus 16 all over 36. And what's 21 minus 16? Well, it's 5. So we actually get 5 over 36. Okay? And then 5 and 36 don't have any common factors. So 5 over 36 is our answer. Okay. All right. So I know these are hard, so I'm going to do a couple more. Okay, so that was number 5. Let's do example number 6. So for example number 6, we have 5a over 11 plus 2a over 3. Okay, 5a over 11 plus 2a over 3. So here, you want to multiply each denominator by what you're missing. And if it's not clear to you what you're missing, since these are both prime numbers, you could just multiply them to get the LCD. So that's one way of doing it. Or you can write out the LCD the way we've been doing. But I think most people can see that since we have 11 there and a 3 there, we're missing a 3 here. Okay? So for the first denominator, we need to have a 3. So we're going to multiply the top and the bottom by 3. Okay, whereas for the second denominator, we're missing 11. Okay, so we multiply the second fraction by 11 on the top and the bottom. Okay? All right, so we're multiplying by what we're missing in each denominator. Okay, and then for our first fraction, multiplying straight across, we have 3 times 5 is 15a over 33 And for the second fraction, 2a times 11 is 22a over 33. Okay, so we actually have the same denominator now. They're both 33, which is what we wanted. So now these are like fractions. So we keep the denominator and we add the numerator. So in the numerator, we actually have 15a plus 22a. And this is all over our denominator, which is 33. Okay? And then in the numerator, we actually have like terms here. So 15a and 22a are like terms because they both have the same variable, a. So 15 plus 22 is going to give you 37. So in the numerator, we actually get 37a. So we have 37a over 33. Okay, 37a over 33. And 37 and 33 don't have any common factors, so we're actually done with the problem. So that's our answer. Okay, cool. So I want to do at least a couple more examples. Okay, so that was example number 6. Next one is number 7. Okay, so for example number 7, we have 2y over 3 minus 1 over 6. 2y over 3 minus 1 over 6. So for this problem, you probably don't need to find the LCD because it should be pretty clear to you what we're missing in the first denominator. Well, for the second denominator we have 6. For the first denominator we have 3. So what are we missing in the first denominator? 2. Because 2 times 3 is 6. Okay? So we're going to go ahead and multiply the first fraction by 2 on the top and the bottom. Okay, so multiply the top and the bottom by 2. So that's going to give us 2 times 2 is 4y over 9. Sorry, not 9. 2 times 2 is 4y over 6, because 2 times 3 is 6. So we have 4y over 6 minus 1 over 6. Okay? And now these actually have the same denominator. So they're like fractions. So we keep the denominator and we subtract on the top. Okay, so on the top, we actually have 4y minus 1. And then this is all over our denominator, which is 6. Okay, so we get 4y minus 1 all over 6. Now you can't combine these because they aren't like terms. This term has a y, this term doesn't have a y. So this is actually our answer. And once again, you can't divide the 4 and the 6 because this term has a 4, but that term doesn't have a 4. So you can't just cancel these out. So 4y minus 1 all over 6 is actually our answer. That's as simplified as it gets. Okay? Cool. Alright, so for our next example, I wanted to do a problem that has a variable in the denominator, just so you can see that, because that's a little bit tricky. Okay, so for example number 8, we have 11 over 12 plus 14 over x. 11 over 12 plus 14 over x. So this is probably strange the first time you see it because you have different denominators, but they aren't both numbers. One of them's a number, the other one is a variable. So what you do is you still multiply by what you're missing. It's just what you're missing here is actually the variable, and what you're missing in the second denominator is actually the number. Okay, but you're still going to be doing the same process we've been doing. So we multiply by what we're missing. So again, for the first fraction, we're missing an x. So we multiply the top and the bottom by x. And then for the second fraction, what are we missing here? Well, we're missing a 12. So we multiply the second fraction by 12 on the top and the bottom. Okay? So after we do that, then we're going to have 11x over 12x plus 12 times 14. If you don't know what that is, you can use your calculator or you can write it out vertically. But 12 times 14 is 168. Okay, so for this top right numerator, we're going to have 168 over 12x. Okay, so we still just multiplied by what we were missing. It's just what we were missing here was an x, and missing over here was a 12. All right, and now we can combine these two fractions because they're actually like fractions now. So they have exactly the same denominator. Each denominator is exactly the same. So how do we combine them? Well, we keep the denominator and we add the numerators. So this is going to give us 11x plus 168 all over 12x. Okay? 11x plus 168 all over 12x. So that one's a little bit trickier, but hopefully you got the idea. Okay, so I think I'm just going to do one more example. Okay, so this is problem number 9, example number 9. For this one, we have 5y over 72 minus 5 over 9. Okay, 5y over 72 minus 5 over 9. So once again, you want to look at these denominators and see what you're missing. So does 9 go into 72? What do you do if you don't remember your times tables? Well, you can do 72 divided by 9 on your calculator. 72 divided by 9 is 8. 8 times 9 is 72. So then my question for you is, what are we missing from this denominator? Well, here we have a 72. Here we have a 9. Well, 9 times 8 is 72. So we're going to multiply this second fraction by 8. So we multiply by 8 on the top and the bottom. Okay? So then that's going to give our second fraction is now going to have 9 times 8 is 72 on the bottom. So we have 5y over 72 minus 5 times 8 is 40 over 72. Okay, so 5y over 72 minus 40 over 72. And now these have the same exact denominator. So what do? They're like fractions. So we keep the denominator and subtract the numerator. So this is going to give us 5y minus 40 on the top and 72 on the bottom. And you could factor out a 5 on the top, but the truth is it's not going to change anything because 5 doesn't go into 72. So this is actually going to be our answer. We can't simplify this anymore. So our answer is 5y minus 40 all over 72. Cool. Thanks for watching.